Okay, so the fundamental theorem of calculus is actually the linchpin of both integral calculus and differential calculus. It's the linchpin. In other words, it's saying that the derivative of a integral is the regular function, okay, which is also equal to the integral from a to b of f of x dx, which is equal to the integral f of b minus the integral of f of a. Okay, so it just works that way. It's just really nice just how it works. And so when you're working with this stuff, just remember, do your upper bounds first and then minus the lower bounds second. So we'll do some examples. Okay, so taking a look at this first one, the integral from 4 to 0 of the square root of x times x minus 2 dx. Okay, so when we work on this one, we set up, we should probably distribute that square root of x. Okay, so first off, we set up our integral part right here. Remember, we're going backwards on this one. Okay, so this part should be x to the 3/2, because remember we're adding exponents, so we distribute this part right here. We distribute it to each part. Okay, minus 2 times x to the 1/2. I just like to keep the rational exponents. Just makes it a lot easier, nice and neat. Okay, so first off we do the integral. And so the integral is going to be 2/5 times x to the 5/2, okay, minus 4/3 to the 3/2. Okay, remember the power rule is what we're using here. Okay, and then we have 0 up here, and we'll have 4 down there. Okay, and then when we do our actual calculations, you're going to notice we're going to have a 0 in the beginning, so it's just going to be straight up 0 minus 2/5 times 4 to the 5/2. And let's put a parentheses in front so we have grouping symbols. Now when you're doing these actual things, you do have to follow the grouping symbols like no other. And then we have 4/3 times 4 to the 3/2. Okay, and this is going to turn into negative 32/15. Okay, and that's okay to have a negative like that. Alright, now taking a look at another one right here. Okay, so when we're working on this integral right here from 1 to 2 of 2w to the 5th minus w plus 3 over w squared, I would strongly recommend you can't do integrals of division type problems. So try dividing everything by w squared. Okay, because now that we have 2w to the 3rd minus 1 over w plus 3 over w squared, we can actually treat this as a really nice problem to actually work out all our computation. Okay, so first off we need to find the integral, and this should be 1/2 w to the 4th, and I'm just using w just to show you guys this stuff. Now if you remember your integration rules, when we do the integral of a reciprocal, it becomes the natural log of the absolute value of the w. Okay. Oh, and I forgot my minus sign, so let's get that in there. So I go minus the natural log of w. Then this one's going to become minus 3 divided by w. Okay, and then we actually have our notation for the integral. And it's going to be 2 up here and 1 down here. Okay. Okay, so we put in our numbers as we calculate. Hold on. All right, so it turns into 1/2 times 2 to the 4th minus natural log of 2 minus 3/2 minus the entire difference of 1/2 times 1 to the 4th minus the natural log of 1 minus 3, which turns into 9 minus the natural log of 2. Okay, so the fundamental theorem of calculus just allows us to be able to work through this and to be able to actually find these areas. And these are technically areas underneath, but they're also calculations, okay? All right, that's it for fundamental theorem of calculus. And just remember, the derivative of an integral is the actual beginning function. Okay, and that's the linchpin of linking integral calculus with differential calculus. Okay? All right, talk to you guys later. Bye.